Hey everybody, it's Mr. Carr again. Today we're going to be looking at 1.1 day 3, solving absolute value equations. Okay, so let's first talk about what is an absolute value. Absolute value is the number's distance from zero. This number is always going to be positive, or technically zero if you're doing absolute value of zero. What that means is, we'll come back to this part, this solving here. If I look at it, for example, on a number line, here's zero and go 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. So let's look at like -3 versus 5. Actually, let's go to 3, in fact. If I look at this one, how far is it away from that middle zero part? It's 1, 2, 3 away, and so is this one. That's why no matter what, the absolute value of a number is a positive number. Unless you're looking at the distance from zero, which is just zero. So we want to solve this. So when we think about this, if I take the absolute value of x and that equals 5, we know from this number line, there's two possibilities there. And that's really what's driving our equations and our solving today. We're looking at more than one possibility of getting to our absolute value. So in this case, I could split it up when I have an absolute value of x equals 5, I could split it up as two possibilities. I could say that x equals 5, or I can say that x equals -5. Really straightforward. But what we can do then is we do that with multiple things here. So we want to solve and then check our solutions real quick on these. So for example, in this case, again, if the absolute value of this right here comes out to a 7, there's two possibilities. Either x minus 5 equals 7, or x minus 5 equals a -7. So we just solve out both equations to come out to our answers. So here I'll add 5 over, so I get x equals 12. And here I'm going to add 5 over, so x equals a -2. So according to this, there's two possibilities that work. It's 12 and -2. Here's my check real fast. The absolute value of 12 minus 5, does that equal 7? Absolute value of 7 equals 7. That's good. And then we do over here, we go -2 minus 5, which is -7. And that also checks out. So we're good there. Next one, same idea. 5x minus 10 equals 45. 5x minus 10 equals a -45. Okay, so from there, do my normal solving steps. We're going to add 10 to both sides, so 5x equals 55. Divide by 5, and I get x equals 11. Over here, we add 10, so that 5x equals a -35. And then divide by 5, so x equals a -7. So we try out both of those just to be on the safe side. We got 5 times 11 minus 10. See if that equals 45. And then 5 times a -7 minus 10. And see if that equals 45. So what we get here is 5 times 11 is 55. 55 minus 10 is going to give me 45. This is -35 minus 10 is a -45. So in both these cases, they check out. Okay, so we're good. Before you can solve an absolute value equation, you need to make sure that the absolute value is possible. Okay. Sorry about that. I just totally blanked. It's not about whether or not it's possible. Make sure the absolute value is isolated. Okay. So what that means is we need to get the absolute value symbol by itself. Very similar to these. These were already isolated. These two are not. So before we can do any kind of like splitting it up as two possibilities, we have to first add 10 over here in this case. So the absolute value of 3x minus 9 is equal to 24. And now I can split them up. I can say that 3x minus 9 equals 24. 3x minus 9 equals a -24. Okay, so then I'm going to go through and do that through my normal steps. So I'll add 9. So 3x equals a 33. Divide by 3, and I get x equals 11. Add 9 here. So that 3x equals a -15. And then I divide by 3, so that x equals a -5. Okay. I'll let you check them. You can plug them in and try them out for yourselves. Over here, we're going to start by subtracting 4 to both sides, so that the absolute value of 3x plus 6 is equal to 0. Well, remember, if the absolute value of something is 0, that has to be 0. So there's only one possibility here. 3x has to equal to 0. So I could subtract 6 over. So 3x equals a negative 6, and then I divide by 3, and I get x equals a negative 2. So I only get one answer here because in this case, our absolute value comes out to a 0 at that point. One other thing to help isolate, if I look at an example like this, we don't have to finish this problem out, but since this is 5 times all that, it's kind of like with 5 times parentheses, like with grouping symbols, we can actually divide out first. So this becomes the absolute value of x plus 1 is equal to 3. And then from there, solve it out the rest of the way. So we're looking to isolate this even with multiplication and undoing it with division. Or even with division, we can do that as well. Okay. The last thing we're going to cover with this one is potentially extraneous solutions. So you need to check your solutions. This is why you do want to plug it in every time. Check your solutions because you may end up with extraneous solutions. These are ones that are apparent solutions. You did all your work, you solved it out, and everything was good, but these are apparent solutions that must be rejected because they do not work in the original problem. So let's take a look at a couple of cases here. So we'll start with this one. We know that 2x plus 12 is going to equal to 4x. 2x plus 12 equals a negative 4x. From here, I'll bring the subtract 2x over. 12 is equal to 2x, and then I divide by 2, and I get 6 for x. Over on the other side, if I subtract 2x over, 12 is equal to a negative 6x, and then I divide by a negative 6 here, so that negative 2 becomes x. But when I plug those back in, the absolute value of 2 times 6, plus 12 equals 4 times 6. So the absolute value, this is 2 times 6 is 12, plus 12 is 24, equals 24. That one checks out. But over here, 2 times a negative 2 plus 12, equals 4 times a negative 2. So when I do this one, we got 2 times a negative 2 is negative 4, plus 12 is a positive 8, equals a negative 8. That does not work out. The absolute value of 8 does not equal to negative 8. So this one is not possible. That's my extraneous. I only have one good answer here is 6 plus x. Okay, over here, similar idea. Let's take a look what happens. So 4x minus 1 here has to equal to a 2x plus 9. But 4x minus 1 can also equal to, I like to do a negative 2x plus 9 in parentheses. Okay, from there, I distribute the negative sign. Well, I'll do this one. I'll subtract 2x. Okay, so that 2x minus 1 equals 9. Add 1 over, so that 2x equals 10. Divide by 2, and x equals 5. Over here, we got 4x minus 1 equals a negative 2x minus 9. We'll bring this over here, so we're going to add 2x. And I'm also just going to add 1 at the same time here. Save a little bit of space. So that's gone, and that's gone. We get 6x is equal to a negative 8. Divide by 6, and I get x equals a negative 4/3. So now we're going to try this out to see if they actually both work. So actually, you know what? Let's just do this as another page. Okay. It's taking up a lot of space. So we could do 4x minus 1. 4 times 5 minus 1, the absolute value of that, does that equal to 2 times 5 plus 9? So this is 20 minus 1, so that turns into the absolute value of 19. 10 plus 9 is 19. That one checks out. Let's go over here. And let's just go a little bit lower. So then we have 4 times a negative 4/3 minus 1. Absolute value of that compared to 2 times a negative 4/3 plus 9. Okay, so if I do that, that's going to be a negative 16/3 minus 1 equals a negative 8/3 plus 9. Negative 16/3, that's going to be a negative 19/3 right there. Negative 8/3, let's see here, that's going to be 27/3 instead of a 9. So that turns into a positive 19/3 there. So we get the absolute value of negative 19/3. Does that equal to 19/3? Yes. So actually, both of these answers work out. Okay. So that is it for our inequality, or sorry, our absolute value equations. Um, Again, to be on the safe side, you always want to double check them, plug them back in, but it's based on the fact that an absolute value has two possible answers, usually a positive and a negative version that has the same distance to zero. Not always, but usually. All right. That's it for today. Take care, everyone.